In this video, I'm going to show to you how to set up a video streaming application which uses Adaptive Bitrate Streaming using the HLS protocol from Apple with React on frontend, NestJS on backend, and AWS Cloudfront to distribute the content using signed cookies. So if you go back here to the application, we open up the network tab, refresh the page, and start seeing the content. We can see here that we have the M3 U8 file and the TS files, and some of them we will see here on the request that we are passing the signed cookies from AWS to have access to the file because they are protected. And that's it. If you are interested in this, follow me until the end of the video. Hello everyone, this is Marco speaking. The video we are about to watch right now is a very long video. So to quickly help you out to find what you want to watch, I created these chapters. These are the main chapters for the video, but depending on some circumstances, I may create more chapters later on. But basically these are the main ones. If you want to watch the same chapters on the playback bar from YouTube, you can hover your mouse on top of the playback bar and then you're going to see the same chapters plus a few more ones depending on some circumstances. But basically these are the main ones. So the introduction is the one that we just watched before the channel introduction. The video summary is this one that we are watching right now. Backend part 1 is the chapter where we initially create our NestJS project, which is our backend code base, and then we're also going to create a service responsible to read a regular MP4 file on the first bucket on S3 and convert the file to using the HLS protocol with media convert, AWS media convert. The next chapter we're going to set up our front-end project using React and Vite. This is going to be the first part of the front end where we basically set up the project, the front-end project. The next chapter, we're going to set up our Cloudfront distribution and connect it with an S3 bucket. So Cloudfront and S3. The Cloudfront will read the data on the second bucket on S3, and we're also going to set up the security on our Cloudfront distribution using signed cookies to prevent unauthorized access on this bucket. And as I said previously, we're going to use signed cookies for this. The next chapter, we're going to finish our backend part. We're going to connect our backend with the Cloudfront distribution, and then we're going to generate the signed cookies and the proper URL for a file to access the file on this Cloudfront distribution. The next chapter, we're going to finish our front-end part, and then we're going to connect our front-end to the back-end. So the back-end will send the data to the front-end, which is the URL to access the file inside the Cloudfront distribution, and use signed cookies. And then we're going to finish our video. So basically these are the main chapters for our video. So here you can see also the timestamps for each chapter so you can quickly find what you want to watch. So I hope you enjoy, and let's do this. Recently, I had to build a real-world application with these same specs, and I struggled for months to make signed cookies on AWS to work properly. And I've done my research on the internet, and I found out that multiple engineers from different companies, they had the same problem, and some of them actually decided to pay the premium support on AWS, which at the time that I'm recording this video costs $10,000 per month. So once I found a solution for it, I decided to share it here on this channel for free. So let's see the steps how this project is going to work. So how this project is going to work. So originally we're going to take one video file that we want to distribute using the HLS protocol. We're going to get this file is sent to the first bucket on S3. Let's call this bucket 1. So after sending the file to bucket 1, we're going to call media convert on top of this file in this bucket. So media convert will read the file on bucket 1, and it will generate multiple versions of this file. So let's suppose, for example, we're going to use one file here which is 1080p. So we're going to use this file to generate multiple versions of the same file in different resolutions. For example, one version will be 1080p, the second version will be 720p, the third version will be 480p, and the fifth version will be 360p. So basically we're gonna create multiple versions of the same file in different resolutions. So depending on your internet connection, the speed of your internet connection, the browser will select different versions of the same file for you to watch it. And so we're gonna call miniconvert to generate the HLS versions for the file, and then we're gonna wait the HLS data to be generated, and these data will be sent to a second bucket. Let's call it bucket 2. So bucket 2 will receive multiple versions of the same file using the HLS protocol that came from bucket 1. After doing this, we're gonna set up signed cookies access on frontend using Cloudfront. So we're gonna build our NestJS backend, which will send the cookies for the user on the frontend app. So steps 1 and 2 and 3 are to generate the content to be accessed by the frontend. Step 4 is to have access to the content generated using HLS protocol. So we're going to create two applications, the backend, which will be made using NestJS, and the frontend, which will be a simple React application. So the NestJS application, which is the backend, will send the cookies, the signed cookies, to the browser application. So the browser will receive the cookies, and the cookies will be sent to the Cloudfront distribution. So this is going to work basically like this. So this is a diagram that represents how the process will going to work on front end and back end once we have the HLS data to be used by the browser. So the user using the front end app, which was made using React, so the user will request file data to the back end. So the front end will receive some data, the back end will send back to the front end some information about the file, like the file URL to be accessed inside the Cloudfront distribution, along the signed cookies. So the back end will send the cookies and some file information to the front end. The browser will receive this information and will send this information to the Cloudfront distribution using the signed cookies. So once the Cloudfront distribution receives this and validates the access using signed cookies, the Cloudfront distribution will request the data to the S3 bucket, which is bucket 2 that we described previously on our project steps, and the bucket will return this information to the Cloudfront distribution, and the Cloudfront distribution will return the M3 U8 file to the frontend app. The M3 U8 file is the playlist file which controls different resolutions to the front-end app to use. And that's pretty much it. So let's keep going. One thing that I think is important to mention is that when I was doing my research on this, I did not find some good practical information about signed cookies from AWS. I actually found a lot of stuff related to signed URLs, but I did not find multiple information and some examples using signed cookies. So this is another reason why I decided to record this video, because multiple examples on internet are about how to use signed URLs with AWS, but very few content are about how to use signed cookies. And that's pretty much it. This is why I decided to record this video. So let's keep going. Before we proceed, if you like this kind of content, just give me a thumbs up, share this video with your friends, and subscribe to the channel so you can learn more about AWS infrastructure. And never forget that the more you learn, the better you become, and more value you can provide. So let's keep going. Okay, great. So these are the buckets that I created for this project. This is the bucket 1, which contains the pure file to be transformed into the HLS file format. So this is a sample video which is a 1080p height resolution. So I'm going to convert this file into multiple versions using the HLS protocol. And this is the bucket 2, which will contain the HLS data. For now it's totally empty, but we're gonna add stuff here after the transformation. So the next thing that we're going to do is to create our NestJS project. So initially I'm going to create a simple NestJS project. So let's open up here in terminal, and what I'm going to do here, I'm going to do nest new. I'm going to start a new NestJS project. I'm going to call it mpcsg ABS video management. I'm going to use Yarn because I like to use Yarn. In a few minutes we're going to have our project ready.
A few moments later.
Okay, great. After a few minutes, we have our simple NestJS project. So let's enter the project and open up the project on VS Code. Okay, perfect. So this is the simple NestJS project that we created. And let's proceed with the things that we need to do here. So the first thing that we need to do is to create a new module to contain the whole code for the ABS project. So I'm gonna do nest g module ABS for Adaptive Bitrate Streaming. If you want to add like HLS, it's up to you. Perfect, so now we have a new module here, which is the ABS module. So I'm going to create here a new controller, which is going to be nest g controller ABS. Perfect. So now we have our new controller, and let's create here a new service. We're not going to use the Nest CLI here for creating the service because we're going to make some changes in the service names. So we're going to have two services. The first service will be responsible to generate the HLS data for a file. The second service will be responsible to manage the file access to the HLS data. So the first service will be responsible to create the data, and the second service will be responsible to give the front end access to the data. So let's create the first one. Let's call it ABS generation.service.ts. Perfect. Now let's do a few things here. Let's recall it ABS generation service. So this is going to be an injectable. We also need to install the AWS SDK media convert library. So let's do this. Yarn add and the media convert library to call media convert and to generate the data. Perfect. So let's create here our main function to generate ABS content for a file on an S3 bucket. So here we need a few parameters. Let's define a new interface for it. Okay, so let's define here the interface for the for containing the properties to pass to the function. Generate ABS content input. So we're gonna pass here the input S3 key, and we're gonna pass the base output S3 key. So here we know it comes from bucket 1. Here for this one, it will be saved on bucket 2. We don't pass the final key for the output because when we use the HLS protocol, we pass the base folder, the base key on a bucket, and multiple files will be created inside this base key. And if you want to pass some tags as well to media convert, you can pass it here. So generate ABS content input. So let's define a few things as well. The first thing that we need to define here are the objects for the media convert configuration to generate the HLS output. So I'm going to create here a new file. I'm going to call it ABS constants.ts. So these are the definitions which comes from the media convert module. Perfect. So here we have the output HLS for 1080p, 720p, 480, and 360. Basically, I'm changing a few things here. I'm changing the output width and height, and also changing the bit rate for the files, for the video and the audio. So when we drop the quality for the video and audio, the final output will have a lower quality on each version. So let's go back here to our module, to our service, sorry. And what we're going to do here. So we need a function. We need a function to define which outputs we're gonna use for our file. I'm gonna explain to you in a few minutes, in a few moments, what this function is doing. So the thing is, let me put this. For now, let me delete this. So the thing is, when we send a file to the bucket, we need a way to check the video height for the file that we're gonna transform. So for now, I'm passing in a hard-coded manner that the file is 1080p, but you can use some software like FFmpeg or FFprobe to check the video resolution and extract the video height. So with a library like this, you can extract the video height, and then based on the video height, you define. So for example, if the video height is greater or equal than 1080p, then we include in the final output the 1080p version. If the video height is bigger or equal than 720p, then we include the 720p, and the same for the other resolutions. So you're gonna include in the final output array the different resolutions based on the original video height. So for example, if your original file is 480p, you cannot generate 1080p or 720 for your HLS file. Why not? Because you cannot upscale the resolution without making some things in the file. This is actually, you can do this quite well using artificial intelligence, but with regular methods, the output's not very nice. So for adaptive bitrate streaming, usually we do for lower resolutions. For example, if the file is originally 480p, then you only generate equal or smaller resolutions for the HLS version of the file. So for the file that we're going to use, we know that the file is 1080p, but for a real application, you need to check this programmatically using some software like FFprobe that I mentioned previously. So we have this function to get the output qualities for our final video. So let's call it here. So the output qualities. Hold on, let me do something first. I'm gonna create a new folder here called VS Code. Settings.json. Editor format on save. True. Editor default formatter. I'm going to use this one. Okay, perfect. So now we have a linter here in our project. So after doing this, now we need to trigger the HLS generation for a file. After doing this, we need to trigger the HLS data generation for a file. So I'm going to create here a new function, async trigger HLS content generation. This is going to be private, and this one is going to be our entry point for data generation. So here we pass the input, the output, and the tags. Perfect. So what parameters we need to pass here in this function? We need to pass the input S3. Actually, we're going to pass the S3 key, the output S3 key, and the video qualities array. So let's keep going. So let's create the job params object to be sent to the media convert library, which is going to be this. So we need to define out as well our media convert queue and the IAM role for our application. I'm going to add these two in this constants file here. Let's go back to media convert. Let's go to media convert and get this information. Media convert queue and the default queue. Let me get the ARN for it. So here on the constants, export const AWS media convert queue, which is this. So let's pass it here. We also need to define the role for it. So for the role, you can create the role on IAM. You go to IAM and create the role for it. Role. And you click here to create a role. And then you pass media convert. Next. And then you add the permissions for media convert to work properly. So like, for example, S3 full access and other information. In my case, I already have here a media convert role, which is media convert default role. So this is my role for media convert. I'm passing here a few information. Actually, this is a bit outdated and it's not going to work for the project, but I'm going to make some changes here. So we need to pass a media convert role for your project using the ARN. So let me go here to the constants, export const AWS media convert IAM role. Perfect. So let me import here the IAM role as well. Let's pass here the type we need to define, we need to use here, create job request from the media convert library. Perfect. So the video qualities is the array. Let's import here input S3 key, base output S3 key, and video qualities array, which is this one. And for the segment length, let's define here as well. So we're going to define for now that every HLS, so the way HLS works is basically by chunking the original file, just by splitting the original file into smaller files, into smaller chunks. So we're going to define that every file will be split into multiple chunks of 10 seconds each. So we define here this information, and then let's pass it here segment length. Perfect. Let's define here this variable as well. So I'm gonna pass here. I'm gonna explain to you what I'm doing here in a few moments. Actually, here we're passing the base output key. Let's define. So for this, for destination, we actually need to pass the URI instead of the key. So if you remember well, the output is actually this bucket. So for output is going to be S3 column / this, the bucket name / and the output key. And we're also going to pass a HLS prefix. So this is actually interesting because if you want to try different adaptive bitrate streaming protocols like MPEG-, beyond the HLS, you can create a suffix here for each protocol. So for example, the output key based on your rules for your application / the protocol / the content for this protocol. So if you want to do, for example, the same for MPEG-, you can pass, for example, the MPEG- suffix here, and all the MPEG- content will be generated inside this base S3 URI. So S3 colon / the bucket name / the base key and the HLS prefix. This is going to be where the HLS protocol for this file will be generated. Here we need to pass the key as well. So let's create here. So it's going to be S3 colon / and the bucket 1 instead of bucket 2. It's going to be bucket 1. And then we pass the input S3 key. Perfect. So if you want to pass tags as well. Perfect. That's pretty much it actually. And then we call the media convert service. But before we do this, we actually need to define the media convert inside this service. So let's define here our constructor, actually the service. Let's import here the client on our module. And inside the constructor, we are going to create a new instance for the media convert client. Perfect. So here on this function, we trigger the media convert service. We also need to import the create job command from media convert library. Perfect. So the response is the media convert.send, and then we pass the create job command for media convert service. But before we do this, let me update the permissions for the IAM role, because so here we have the job params. We need to pass the queue for the media convert queue. We need to pass a IAM role to call media convert with proper permissions. And here we pass the actual configuration. The HLS protocol was created by Apple. This is why I define it this way. And then here we pass the segment length. We pass some extra information. You can have all of this information using ChatGPT. Basically, you can say to ChatGPT, generate the media convert job output for HLS protocol. And ChatGPT will create some basic code for you. And then you can customize based on your requirements. And here we pass the video qualities in different qualities like 1080p, 720p, 480, 360, and so on. So here we pass the video qualities. But for our IAM role, this is my IAM role. I need to make some changes on my IAM role to allow the code to read and write on these two buckets that I just created. Actually, let me create a new role with you to be used here. So media convert. So I'm gonna pass here these two policies for now. Next, I'm gonna call it MPCSJ and media convert ABS video role. It's up to you. For now, we're gonna have these two permissions: API gateway and full access for S3, and create role. Let's search for it. This is the role that we just created. Let's check here the policies that we have. We have full access to S3. It's not recommended for real applications to have full access to S3, but only the buckets you need. So I'm gonna pass this ARN to the application. Perfect. And let's go to our controller. Let's import here our new service inside this controller. So I'm going to do constructor and then private read only ABS generation service, which is going to be the ABS, this one. Let me copy the name, generation service, and then you pass it here. Perfect. But this is not going to work because I need to define the controllers here inside the module on our NestJS module. So I'm going to do providers, and then I pass here the ABS generation service. ABS generation service, which is this one. And now we can define it here on our service. And then let's create a new function here on our controller to generate ABS data for file. So this is gonna be a post method, and let's define the method here to receive an object which contains the input S3 key and the output the base S3 key for generating our HLS file. So if you remember well, let's go back here to our service, and then here we defined the input S3 key and the base output S3 key. So I'm not gonna do like the other projects to validate the format for the object. I'm just going to pass it here. So I'm gonna say here that this is, let's pass the body here and the data, which is going to be this interface here that we defined. Actually, let me pass here this somewhere else. So I'm going to say abs.model.ts. I'm going to do something more simple this time. I'm not going to validate the structure for this interface. So we say that this is an object of this type, and let's import it here as well. Perfect. Oh yeah, we also need to call the function here. .trigger HLS generation. And then we pass the input S3 key, the base output, and the tags. So let me check here what's wrong. Oh yeah, we need to pass the video qualities as well. Oh sorry, the video qualities is going to be the output qualities. Why is this wrong? Because, oh, okay, so the name is a bit different. Or we can basically rename this, but it's fine this way. So here we call this function, we in theory, this function is really the file key from the bucket, checking the video height, and based on the video height, we'll define the final HLS qualities for use to be used on this file. But for now, I'm just mocking here and saying that this is gonna be a 1080p output mocked result. And then here we call this function to trigger the HLS generation for a file. Okay, perfect. So here, what I'm gonna do, await this dot ABS generation service dot generate ABS content, and then we can pass the data to the function, and this needs to be async. And that's pretty much it. Here we call the function generate ABS content, and then we generate the ABS content for a file. Perfect. Yarn start dev. So everything is working. Now let's open up Postman and test it out our application. Okay, perfect. So here on Postman, let's create a new request here, and then I'm gonna say HTTP // localhost on port 3000, and then we're gonna pass the path for our controller route here. So it's basically going to be a post to ABS. Actually, let me do here /generate. So ABS/generate, and it's going to be a post request. And then input S3 key. Let's pass here our S3 key. And we also need the output S3 key. Let's go back to Safari. Let's go back to the bucket, sorry. And this, let's copy the URI. Actually, we could pass the URI, but I'm decided to just pass the key. So let's remove this. We are remounting it actually on our application. And the key, this is gonna be the key inside this bucket here. So I'm gonna say file1 result. It's up to you. This is gonna be the base path for the HLS data to be generated. Let me check something if we already have a slash at the end of our code real quick. So the base output key, yeah, we are not counting the output key that it has a slash already. So basically it's gonna be file1 result slash and the content for the HLS. And let's make a call here. Let's see if this is going to work. Let's go back to our application, And the media convert job was created. Now let's go back to AWS and see if it actually worked. Oh, sorry, this is wrong browser. So here we go back to media convert, see all the jobs, refresh the page. This one is working right now. So here we can see that we have 4 versions of the same file. So the mpsjabs video bucket 1 / sample video 1080p, which is the file, the input S3 URI, which is going to be used, and we are going to generate 4 versions of the same file using the HLS protocol. So in a few minutes, this is going to be ready.
A few moments later.
Okay, great. After a few minutes, the status is ready, it's complete. So let's check here on our bucket. So let's refresh here. So we have file 1, result, HLS, and the HLS content. So let's break down and check these files a little bit. So what we have here, we have, first of all, we have the M3 U8 file, which is the playlist file for HLS, and we have the TS file, which is the actual content, which is a chunk from the original video. So what we have here, we have the sample video underscore M1080p M3 U8, and then we have the sample video underscore 1080p underscore 1080p M3 U8, and the other ones have the 1080p at the end, 360, 480, and 720. So this is the master playlist, which controls the other ones, the other playlists, and each playlist here, the small playlist here, controls the chunks for the files. So here we have multiple chunks for different resolutions controlled by each playlist. So if we open up here, this one, download, let's check it out, the content for the file. So this is what we have inside the playlist file. This is the base playlist, which controls other playlists. This is the file that we're gonna send to our front-end application, and based on this file, we're gonna control our application. And let's go back here to the bucket and let's check it out, the other one. For example, let's check the 480 here. Download it and open up the file, and this is the smallest one. So here we have all the chunks, the first chunk, the second, the third, and so on, for this resolution of the file. And every TS is a chunk for the original file on this resolution. This is basically how HLS works. And let's go back to the bucket. And that's pretty much it. So now we have one file to work with our code base. Let's stop this. Now we have the code to generate HLS version of a file in multiple resolutions. Now let's go back to, let's create our front end to connect to the backend and request the signed cookies information for one specific file. Okay, great. So I'm going to create a simple React using Vite project for doing the front end. So let's do this. So you can adapt this to any framework you prefer, like Next or Gatsby and so on. So I'm gonna use Vite here for the project, but it's up to you which framework you want to use for your project. So cd my React app. So let's open up the project here on VS Code. So let's check it out here on package.json, and let's start our front end. So yarn dev. Okay, so let me install a few dependencies here.
A few moments later.
Okay, great. Now we installed the basic dependencies for our project. Let's start our front end. So yarn dev. Yeah. Let's open up the front end. Let me close this. Let me close this and this and this. And let's open up localhost on this port. Copy. Paste it. Actually, let me change the port here to be 3000 instead of 5173. So server, and then we pass the port. I want to use port 3000 instead of using this Vite port. So 3000. Perfect. Now let's keep going. Okay, so for our project, we're gonna use video.js. to load the file. Vue.js is a very popular library, so we're going to use Vue.js in our project to load the file using Cloudfront and Signed Cookies. So let me go actually here to guides, and let's open up here React and Vue.js. We're going to use this as a base code to be used here. So let me stop this again, and let me add yarn add video.js. Perfect. So what I'm going to do here, first of all, I'm going to create here a new custom hook, use app.ts. This is going to be our base custom hook, const use app export default use app. Perfect. And then let's go back here to our application. So let me go here to the app again. I should have this counter here. We don't need it, which is this one here. And then remove this. It's gonna break the code. No problem. Remove this. Refresh the page. Oh yeah, actually we stopped it. So yarn dev, if I remember well. Let me refresh the page. Vite plus React. We don't need any of these things. Let's clean the whole thing. Okay, now we have a basic page here. And then let's import our new custom hook. Actually, use app. Perfect. We don't need none of this. What we're going to do here, let's define here actually a new module for our application. So I'm going to call it Vue.js player, video player. So here we're going to pass the video player.component.tsx. So actually it's going to be video player component export default video player component. So here I'm just going to return a basic div and h1 video player. Perfect. So let's import this on our application. Video player. Yeah, it's not really here for some reason. Let's import it this way then. Import video player component. Okay. So we have a very simple text here for now. But what we're going to do here, we're going to implement the Vue.js library here. So it's basically going to be this. So we need to pass here the Vue.js CSS import here. Actually, I prefer to do all of this on a custom hook. Use video player.ts. So this is going to be the custom hook. Use video player, implementing the code base for Vue.js. Export default use video player. Perfect. So let's call it here. So what we need to pass here for this component, I'm gonna do a few things here. So I'm gonna define here an interface, export interface use video player. Perfect. So we pass the video source code, which is a string, a video meme type, which is a string as well. So use video player, and then here actually the props are going to be the same props as the use video player props. Oh, sorry, it should be props here. Perfect. And then we pass the props here. Props. Okay, so what we define here for our application is the video source and the meme type. So for now, let's just commit this thing back. Don't worry about this, we're gonna put it back. So let's go to our use app, the main custom hook. Here we're going to implement the function call to call the backend and to get the information like the signed cookies and the path inside the video, the distribution in the Cloudfront. So let's create a function here, const handle get file info. It's up to you. So what I'm going to do here, so I'm going to pass here a sample S3 file key. So what is this file key? So the file key that we pass here, the sample file key, is actually the file key for the master playlist file, which is this one. If you see the name here, it's a bit smaller than the other ones. So this M3 U8 file is the master playlist file for the HLS protocol. So this is the file key that we need to pass, or we're gonna pass here on our code base. Actually, the file key. And the meme type is going to be a application/mpeg URL. This is the meme type for HLS protocol. So what we're going to do, we're going to make a call on our front end to the backend to request access based on this file key. For making a function call, I prefer to use Axios rather than fetch, so I'm going to install it here. Okay, great. So here on this function, we're going to make a call to the backend code to get the Cloudfront distribution URL for one specific file along the signed cookies. But before we proceed here on this function, there are two things we need to do. We need to configure a Cloudfront distribution and point the Cloudfront distribution to bucket 2, which is the bucket which contains the S3 data. This bucket here, npcsj abs video bucket 2. So this is the bucket which contains the HLS generated data. So we need to configure a Cloudfront distribution with this bucket as a source data. So let's do this. So the next thing that I'm going to do here is go to Cloudfront. Let's create a new distribution. So I'm going to click here, and I'm going to select npcsj abs video bucket 2, which is going to be the origin domain for our data. So we're going to use origin access control to restrict the access to this bucket. Let's create a new OAC. We're going to need to sign requests. So I'm going to say this is the npcsj abs video. It's up to you, it's optional, you don't have to put a description, but for make my life easier here, I'm gonna add it. Let's click to create. Okay, perfect. So we don't need origin shield. Let's use for now some of the configurations here. I'm gonna set here get head and options. We're gonna need options for course, and we're gonna restrict viewer access, but we need to create a few groups here. For now, I'm not gonna set this, but I'm gonna set it later. Don't change this for now. We're gonna make some changes here on the distribution behavior for enabling signed cookies properly. But for now, let's just create it. Let me review a few things here. Origin shield. We don't need WAF here for this application. Let's use the only North America and Europe here to save some costs. So let's create a CNAME here. We're gonna need a CNAME. This is important. We need a domain where the base domain is the same as the backend application. So I'm gonna say, for example, npcsj video abs distribution.npcsj.online. The thing is, my backend needs to be deployed using the same base domain. So when I deploy the backend, it should be something like this. Backend app or something .mpcsj.online. The root domain needs to be the same. This is important to make signed cookies to work properly on AWS. So, but for the Cloudfront distribution, I'm gonna call it mpcsj video abs distribution.mpcsj.online. This is gonna be my CNAME. Let me copy this because I'm gonna need it on Route 53. Oh, this is also important. You need to own this domain. You have to buy this domain somewhere. It can be directly here on AWS, GoDaddy, or somewhere else. You need to own this domain and create a Route 53 hosted zone for this base domain. And we also need to create a SSL certificate using Certificate Manager. So I already have here a certificate. So let's go, for example, to Route 53. So I have one hosted zone here, and the hosted zone is for mpcsj.online, which is the domain that I bought somewhere else, and then I created a hosted zone here on AWS for this domain. And once you create the domain, you need to go to Certificate Manager and create a SSL certificate for that host, for that domain on Route 53. So I created this certificate and connected the certificate with the hosted zone. So once you do these two things, you're good to go for Cloudfront configuration. So I attach here this SSL certificate for this base domain, and if you pay attention to the details, Certificate Manager, you will see that the domain is actually here a star.mpcsj.online. So this root domain and any subdomain is valid for this SSL certificate because of the star here. So anything with the base mpcsj.online domain will work for this SSL certificate. So let's keep going. So let's use the default configurations here for AWS. Let's enable IPv6. For now, we don't need to configure anything else. We're gonna make a few changes here for the restrict viewer access. We need to attach some public keys for our Cloudfront distribution and use the private key on our application. But for now, let's just create the Cloudfront distribution. Let me double check a few things here. Yeah, that's pretty much it for now. And let's create this distribution. So you will see this yellow message here because for this to work properly, we need to update the bucket policy to allow Cloudfront to connect to the bucket. So you basically click here to copy the policy, and then you go to the bucket that you connected to the Cloudfront, which in our case is this one, the mpcsj ABS video bucket 2. This is the bucket that we're gonna send the data to Cloudfront. So I need to go here to permissions and go to bucket policy, edit, and paste the policy that we previously created for this, that was created for Cloudfront for this bucket. So, and that's pretty much it. And then you click to save changes. If you lose this yellow message, you don't have to worry, because if you lose this message, you can go to origins and then click here and click to edit, and then you can click here again to copy policy if just in case you lose the bucket policy. Okay, great. So let's wait a few minutes for the Cloudfront distribution to be deployed, and then I'm gonna go to the second step, which is to create the public and private keys for having access to this Cloudfront distribution with signed cookies.
A few moments later.
Okay, great. After a few minutes, our Cloudfront distribution was properly created and deployed. So now let's create the keys to control the access to this distribution. So we need to go here to public keys, and then we need to create a public key for our Cloudfront distribution. So let's click here to create a public key. So I'm gonna call this mpcsj abs video public key. It's up to you. So if you want to put a description like the video key for Cloudfront and AWS video distribution, because I'm recording this video. So for the contents here, you can go to Google and search for Cloudfront, create public key and private key. You will see this link, but I'm gonna attach this link in the video description for you. So you go to this page and then you will see these commands here. So this command will allow you to create the private key, and the second command will allow you to create the public key. So I'm gonna open up terminal and paste these commands and create the keys. Okay, great. So here on terminal, let's copy the first command and paste it here. Now let's copy the second command and paste it here. So now we have the private key and the public key. So for the public key, we need to copy the contents for the public key and paste it there. So if I do cat public key, so this is the content for the public key, just copy it here. Go to Cloudfront distribution, paste it here. So this is the content for the public key, and then let's create the public key. So once we have the public key, which is this one, we need to go to key groups. We need to create a new key group. I'm gonna call it PCSJ AWS video key group. It's up to you. And now we select the public key that we just created, which in my case is this one, and create the key group. Let me double check. So this one, PCSJ AWS video key group, which has this key. Let me double check the key, which is this one. Perfect. Now what we need to do, let's go back to our Cloudfront distribution, which is this one. And now let's update the behaviors. So let's click here, click to edit. So we need to change here to restrict viewer access. If we don't do this, anyone can access the content in our Cloudfront distribution, but this is not what we want. We want to restrict the access based on signed cookies. So let's click here to yes. So based on this, users will only have access to our distribution using signed cookies and signed URLs. So now let's select the key group, which contains the public key and the private key that we previously created, which is PCSJ AWS video key group, which is this one. And that's it. And now let's select the policy for allowing users to connect to our Cloudfront distribution. Okay, great. So for the origin request policy, the one that worked well for me. So one thing to say, which is important, I'm not saying that this is the only way to make it work. I'm saying that this is the way that it worked for me. So the way it worked for me was to pass here course custom origin as the origin request, and for the response headers, I had to create a custom response header. So besides this, for additional settings, we don't need to change anything here. So for response headers, let's create a new response headers policy. So I'm gonna say that this is the PCSJ response headers for AWS video. It's up to you. We need to set up course. We cannot allow all origins to access the application, so you need to restrict a very specific list of applications that can connect. So for example, I'm gonna pass here, for example, http://localhost 3000, which is one origin that can access our distribution. If you have, for example, a deployed application, for example, https://.yourapp.yourdomain.com. This one doesn't need to be the same base domain. So for example, we said previously, when we deployed the backend app, which in our case is the NestJS application, the NestJS application must use the same base domain as the Cloudfront distribution. But for the front end, it doesn't need to be the same base domain. So it can be anything else. But in my case here, for now, I only have the localhost, so I'm only going to add localhost 3000 here. And for the other configurations, so let's pass all headers. Expose headers is going to be all headers as well. For control methods, we're gonna pass all the read methods, the get, the head, and the options. So we need to pass the get, the head, and the options for given access to Cloudfront and our application. And for security headers, I'm going to select a few things here. For strict transport security, I'm gonna use the default value. For X content type options, we're gonna select X. I'm gonna select origin override. For X frame options, I'm gonna select here same origin, and let's remove here the origin override. For now, it's only going to be same origin. For XSS protection, so I'm gonna select here enabled and click to block here. For referrer policy, I'm gonna select here strict origin when cross origin, this one. For content security policy, we can keep it disabled. So these are the configurations on Cloudfront response headers that it worked for me. So one thing which is important to mention is that passing these options, you need to pass these parameters. Options is important for cores. And you cannot allow everyone to connect, because when you allow everyone to connect to your Cloudfront distribution, the front end will not have proper access to the distributed content using Cloudfront. So you need to pass a very specific list of origins that can access this Cloudfront distribution. So for now, I'm just passing the localhost, but if I have another application like a deployed app with a custom domain, then I pass it here as well. But for now, since I only have a localhost application, then I'm only passing this origin here, the methods, and that's pretty much it. If you have some doubt here, just pause the video and analyze the configurations that I'm passing here. And then I click here to create. Oh, okay, this is because of the name. Okay, so I need to pass here. I cannot use space here for the name, so let me remove the space and create. Perfect. Let's go back here to Cloudfront distribution, refresh this list. Let's go to our custom, which is this one, MPCSJ response headers for ABS video. This is the response headers policy with the proper permissions for our application. One thing which is important to mention is that when I was recording this video, I noticed that I passed one information wrong. Let's go back here to our response policy. So let's go to Cloudfront. Let's go to our response headers policy, view policy. Let me close this again and open up again. So let's go here. This is our response policy. I forgot to disable this flag here. So previously on this video, this flag was enabled, but you must disable it this way. So origin override and access control allow credentials, both of them must be disabled. So this is the actual response headers policy that worked in the end of this video that you'll see. So pause the video and check everything. So once I've made these changes, everything worked at the end of the video. So again, these two flags must be disabled to allow the code to work properly. And that's it. So again, you need to enable restrict viewer access, passing yes, and then you pass a trusted key group, which is the key group that contains the public and the private key that we created previously. Actually, the public key, the private key, we're gonna pass in our code base. So the cache key and origin requests, the cache policy here, we can pass this one recommended for S3. The origin request policy, you can pass course custom origin. The response headers policy, you have to create a custom policy with your domains and the proper HTTP methods that allow cores to work well. And then you click to save changes. In a few minutes, this deployment will be ready, and then we have to go back to the S3 distribution and configure course access on our S3 bucket as well. Okay, great. Now that our Cloudfront distribution is properly configured, let's go back to the second bucket, which is the bucket that we connected in our Cloudfront distribution, which is the bucket 2. Let's go back to permissions, and now we need to go here into course configuration and click to edit. And then we need to pass pretty much this. An ID, allowed headers can be anything. So the allowed methods here will be get and head. We cannot pass options here. S3 does not allow options method here. So on allowed origins, we need to pass the same list as we passed previously in the Cloudfront distribution, localhost and something else if you have another domain. And I'm using these exposed headers to make it work. And if you want to extend the cache here, I like to use a very small number to test my configurations very quickly. If you increase this number, have to wait for the cache to expire to test something else. And that's pretty much it. Now let's click to save changes. And that's it. This is the S3 and Cloudfront configuration that we need to do to make Cloudfront and Signed Cookies to work. Now we need to go back to our application and create the code to grant access to the front end on our backend code. One thing that I forgot to mention is that when we define here the CNAME for our application, we need to create the CNAME on our hosted zone on Route 53. So let me copy here this. Let's open up Route 53. Let me close this and this. Open up here. Let's click here and let's create a new record. So it's going to be npcsj video APS distribution, which is the same name we defined here, dot the base domain. So it's going to be an alias to Cloudfront. And let's select here the distribution, which is already this one here. And we click to create the record. And that's pretty much it. Now we're good to go to connect to our Cloudfront distribution using the custom domain that we created. Now let's go back to our backend app and set up the whole access to Cloudfront. Okay, great. So here back to our backend app, let's create a new service. So I'm gonna call it AWS distribution.service.ts. So this service will be responsible to give access the front end to Cloudfront distribution to connect to get the HLS files. So let me create here export class. So I'm gonna call it AWS distribution service. This is gonna be a injectable class. Injectable. Perfect. So we need to install a few libraries here as well. The first library that we need to install is the Cloudfront Signer from AWS. So if we go back here to our browser and we search for this library, you will see this library called Cloudfront Signer from AWS. And here we install this library, and then we need to use the get signed cookies library here. I'm also going to attach this link in the video description for you to take a look at. Okay, perfect. So let's go back to our application. So here, let's do yarn add this. Perfect. So let's define here the main method to get access to signed cookies for a file. So it's going to be async get signed cookies for file. What we're going to pass here in this function, we're basically going to pass the S3 file key into this function. The file key will come from the front end. The front end app will send the file key to the backend app, which will come here. And here we're going to make the rest of the code to give access to the file key and everything related to the Cloudfront distribution. Okay, perfect. So we also need to define a few constants here. So we need to define the Cloudfront distribution domain, which is the domain that we defined here, which is this one. So let's go back to our, let me clean this. Let's go back to the backend app. So this is going to be our Cloudfront distribution domain. So we need to read our private key. If you remember well, previously we created two files, the public key and the private key. The public key, we send the content to Cloudfront, and we attach the public key into a key group, and then we connected the key group into the Cloudfront distribution. Now we need the contents for the private key. So let's do the same cat private key private.pam. So this is our private key. So let me copy the contents. Let's go back to our application. And then here to constants, export const. So I'm gonna say this is the private key content. Actually, to make my life easier, I'm basically going to add the private key into a string here and then pass here into the code. But this is quite not recommended for real world application. Usually it's recommended to pass the key somewhere else and then eject it in your application. But to make everything easier, I'm just gonna pass the whole private key here as a single giant string. So to read the private key as a giant string, including the break lines properly, actually I'm gonna use, instead of doing cat and private key, if I do this, I don't have the break lines. So to also include the break lines, what I'm gonna do here, I'm gonna do a very small Python application. So I'm gonna read the private key, so with open, and then I pass the private key dot pm, and then I pass as a read mode as r, and then result will be r.read. Perfect. So now I just do res for result, and then I'm gonna copy this. So if you pay attention, here we have all the break lines properly. So when I pass this inside a string, I can read it correctly in our code base. And that's pretty much it. So this is the private key that we're gonna pass to the Cloudfront signer. So let's keep going. Let's go back to the new service. So the private key, const private key, will be the private key content. Perfect. Okay, great. Now that we have the private key, what we need to do, we need to define a few things here. We need to define the URL and the policy which our application will have access to. So I'm going to create, for example, policy. This is the policy that we're going to send to the Cloudfront signer. So we need to define an interval. So I'm going to pass an interval in milliseconds. So 86,400, this is 1 day in seconds time 1000, so this is 1 day in milliseconds. So we pass here, divide by 1000, and this is gonna be, so we're saying basically here that our signed cookies is valid for 1 day. And the resource, we define what we're gonna give access using this policy. So here I'm doing a very simple thing. I'm basically giving access to everything inside the Cloudfront distribution domain. But if you want to restrict the access, you can do it by passing a very restrict string here. Then we create a policy string. Basically, we stringify this policy, and then we call the method get signed cookies. So get signed cookies, and then we need to define the key pair ID. What is this key pair ID? So the key pair ID, const key pair ID, is going to be what? It's going to be the key pair ID from our public key. So if you go back here to distributions, we go to public keys, and then we go to the key that we just created, which is this one. So we copy this ID here, we go back here and pass it here, because this key pair ID is attached to the public key, to the key group, and the key group is attached to our Cloudfront distribution domain. So we pass this key pair ID here into the get signed cookies method from Cloudfront signer. We also need to define the base URL for this file key. So what will be the URL? It will be this. So Cloudfront distribution domain, so basically it's going to be npcsj-video-absdistribution.npcsj.online / a encode URI for the file key. So this is going to be the URL for the master.m3 U8 file, which is the HLS playlist. And the cookies. We also need to define the cookies options. So cookies const cookies options. If you want to use the best practices, you should pass everything here as uppercase key pair ID. Key pair ID and then we pass it here, key pair ID. But I'm not really worried about this for now. So cookies options, and then here we pass the cookies options for passing along the cookies. Let me pass this as a single string. Simple string actually should be an object. So the cookies options, we're passing the domain, which is the base domain, npcsg.online, secure true, and path is going to be everything, same site on. So this is important to know that this does not work on localhost. So the thing is, we're going to create the code, but to see this to work properly, we need to deploy the backend somewhere on AWS and then create a custom domain with SSL, and the application must have the same base domain because we're passing here the domain as npcsg.online. If you try to pass this using a localhost backend, this is not going to work properly. And cookies options, we're gonna need it later as well. So I'm gonna create an interface to define the cookies data to be sent to our application. So cookies database, this is a simple interface which will contain the key value for a cookie and the options for a cookie. And we're gonna do basically this. Cookies result is the cookies data, the interface that we just defined here. And for every cookie that we got from AWS, the key, so we're gonna attach to this object the key, and the value will be cookies.key. Actually, we can pass here already options, and then we pass the cookies options. We don't need this if statement. And that's pretty much it. Again, this is, so if you want to restrict, for example, only one specific subfolder inside the S3 bucket, you should restrict what we will give access to. So for example, file 1, HLS, and then everything inside this path. But to make everything more simple, I'm just passing star here. So this policy is allowing this signed cookies to have access to anything inside this Cloudfront distribution domain and inside the S3 bucket. But if you want to restrict the access, you can pass a very specific path here. And then let's return what we need to return for our app. Return, and then I'm gonna pass file URL is going to be the URL that we defined previously, and cookies will be the cookies result, this object that we defined previously. Perfect. Oh, actually, it's not the URL directly. It should be https:// and then we pass the URL, because here we need to pass a protocol, but when we define here, we did not define the protocol. Okay, perfect. Now let's go back to the controller layer and define a method to connect and use this method here on the service layer. So when we go back to our controller layer, let's define our new service, private read-only AWS distribution service, AWS distribution service. Perfect. On module, AWS distribution service. Perfect. Now let's define a method here. Async get file access or something. So this is gonna be a get, so colon S3 key / access, and then we define a few things here. So we need to define a parameter here and a result. So let's define this interface. This is a very simple interface. If you want to pass it here inside the model, export interface, and then we import it here. And then we reread the path params, which is for now only the S3 key. and then we get the result containing including the cookies. So this is the result using this method that we just defined, which contains the cookies and the file URL. This is the master playlist URL, and this is the cookies for frontend. Perfect. Now let's go back to the controller. Result. Now we need to set the cookies on our response. So response.cookie. We need to import response here from Express, because this is a response object from Express actually. So what we're going to do here, so on result.cookies, which is the object that we return from service layer, we are, for every cookie we pass in the response.cookie we pass the key, the value of the options. But here's the thing, this is not going to work if you just deploy the application. We need to make some coarse changes on our application for this to work properly. So let's do these changes. So the first library that we need to install is a library called cookie parser yarn add, and then we pass the cookie parser. So let's go back to main. Let's make a few changes here. So I'm gonna create a method here called const resolve app middlewares, where we pass an app, which is the AI Nest application. And here we set all the middlewares for our application. So we do app.use, and we pass the cookie parser. Let me import it. We pass the cookie parser, and we do app enable cores, but on a very specific list. We cannot allow anyone to access here. So if we pass a star, which is anyone to connect to it, this is not going to work. We also need to restrict the access to who will receive the cookies. So what we're going to do here, I'm gonna pass a orange list, and then I'm gonna pass all the front end apps which will connect to our application, receive the cookies, and will connect to the Cloudfront distribution. So I'm gonna do for now http://localhost 3000. Again, if you have another domain like https://yourapp.domain.com, you can pass it here on this list as well, but for now I only have this domain. And we pass the credentials true. So this will allow frontend to receive cookies from backend. And now we call the method resolve app middlewares, and then pass the app instance on bootstrap method. And that's pretty much it. This is how we set up the course configuration on our application. So we added the course middlewares here, we added the cookie parser, and we enable course, app enable course, and then we pass the proper origin, and then we pass credentials true. With this, we can send cookies from backend to frontend. So by doing this, our frontend app will have the signed cookies, and the signed cookies will be sent to the Cloudfront distribution. But here's the thing, we cannot make this to work on localhost. So you will have to deploy this backend app somewhere and connect your localhost to the deployed version of the app. If you try to connect to the localhost, it is not going to work. So you can deploy this app somewhere. So I have on this channel some solutions using Elastic Beanstalk and using ECS. For now, I'm going to do a very simple script here to zip the whole project, zip project.sh. So basically we are zipping the whole project. So we actually go back to the previous to the root domain, to the previous folder. We delete the distribution folder for not having outdated code, and then we run yarn build again to build the whole code, and then we zip the code. And this we are gonna send to Elastic Beanstalk. So as I mentioned previously, on this channel, I have multiple solutions to deploy a NestJS app to Elastic Beanstalk and to AWS ECS. which I'm going to attach in this video for you to take a look at. So for now, I already did this and I deployed this app on Elastic Beanstalk. This is the same app that I created previously, and this app is deployed on Elastic Beanstalk. So once you do this, so I created this Elastic Beanstalk instance, you need to connect HTTPS for the application as well. So the easiest way to do this is to create a load balancer along your application. So for example, on my app, I also have a load balancer. I have a load balancer, and on this load balancer, I have the SSL certificate connected to it. So for example, this is the listeners for my load balancer, and I have a listener on port 443 with an SSL certificate. Let me see if you can see it on EC2 console. Load balancer, this is the load balancer for this application. So on port 443, I have the listener, and I also have the SSL certificate, which is the same certificate as the Cloudfront distribution, because it's the same base domain. And this load balancer is pointing to this Elastic Beanstalk application. And besides this, I also had to go to Route 53 and create a domain for this Elastic Beanstalk app as well. So once we do this, we have a deployed app on Elastic Beanstalk with custom domain and SSL certificate with HTTPS. So once we do this, we can go back to our front-end app and connect the access to the application. Okay, great. Now that we have our backend properly deployed, also we have the Cloudfront distribution properly configured, let's go back to front end and finish our application. So right now I don't have anything here displayed. So let's go back here to our code base. I don't remember if I already installed Vite.js. Oh yeah, I already have Vite.js here. So what I'm going to do here on this component is to finish the whole thing. Actually, let's go back here to our use app and let's configure the code to make the call to the backend app and to get the signed cookies. So what we need to do here, first of all, we already have here a sample S3 file key. So let's paste it here. So the S3 file key, I'm using a encode URI component, and then we pass this file key because we're gonna pass this as a path param. So to encode all the characters here on this string without having any issues when sending to the backend, I'm going to encode as a URI component. Perfect. Now let me define here as well the meme type. For now, I already know that this is a HLS, and let's make the backend call. So it's going to be something like this. This needs to be async as well. Let's import Axios here into our application. Perfect. So Axios get, we need to pass this with credentials true to set cookies from backend to frontend. Perfect. Now let's define the interface for the result, which is going to be something like this. Something like this. And the data, the result.data is going to be this interface that we just defined. And now we need to set this in a use state variable on our React application. So let me define here, let me import a few things here from React. Import from React a use state. Oh, sorry. Use state. Perfect. So now I'm going to define here a use state. So for now it's going to be undefined. So the type for this variable is going to be the object that we get from. So the type here is going to be this. It's basically going to be the file URL and the meme type. So we're gonna store here the video information to be sent to Vite.js. So I'm gonna create an interface here to define this information. So I'm gonna call it content to display. content to display. And I'm gonna pass here the video URL, which will come from the backend, and the meme type. The meme type can come from backend as well, but to make the whole thing simpler, I'm gonna pass here hard-coded and undefined. So video content, set video content. Okay, so once we read this, we need to set the video content. The video URL will be the data.file URL. So the file URL, this is going to be the Cloudfront distribution URL that came from the backend, and the meme type. The meme type we already defined here, hard-coded as the HLS meme type. And that's pretty much it. So I need to import something else here from React, use effect. So once we load this custom hook, I'm gonna have here a use effect to make the first call and get the information. So use effect handle get file info. That's pretty much it basically. So when we start this custom hook, we're gonna call this function to load, to make the HTTP call to get the Cloudfront signed cookies and the file URL to access the playlist file. So again, this is going to be the Cloudfront playlist file URL, which is the .m3 U8 file from Cloudfront. And let's return here the video content. Let me do something else. Let me add the linter here, just like we did for the backend app. .vs code, settings.json, editor format unsafe, true, editor as default formatter is going to be this one. And that's pretty much it. Now we return the video content. Let's go back to our app here. So I'm gonna do const this and use app, and here we pass the video content. So I'm basically check video content and the video player component. If we have the video content, then we pass the video player. And we also define here that we're gonna pass a few information, the video source and the meme type. The video source, the video meme type is going to be the video content dot meme type. Actually, what we can actually pass here the same interface, something like this, export interface video info or something like this. And then here we extend the video info. So let's go back here to our use app, and the content to display will be actually the video info. Video info. So here we can basically destructure the object video content. So we pass here the video content, which will go into this component and go to the custom hook. And here we can see the video source and the video meme type. Okay, don't worry about this. For now, I'm gonna still use the information. So what I'm gonna do next, I need to define a few refs here. Let's import from React, use ref. So video ref and player ref. I'm gonna define a few things here. The player will come from video.js, from video.js, and here we need a function to get the video options to video.js. So define here a function get video options. We define the source, which is the video source, the video meme type, and then we pass with credentials to send signed cookies to Cloudfront. Perfect. And here we also need to create a use effect. And for this use effect, we're going to initialize our player. So let me import here as well video.js library, video.js. So inside this use effect, we get the video options from this function here. We basically define the options that we're gonna send. We define the options that we're gonna send to the video player. Define video options to be sent to player. Perfect. Let's stop this for now. And video options. So if we don't have the player ref, we are going to create a video element, video.js, and then we append this object inside. This class is actually here inside, and then we define the whole code. This is actually comes from the documentation here on video.js. Basically, I'm using this code here with a few changes. So basically, the biggest change that I've made was I just removed here this else statement to not update the video information. Basically, this is everything that I've done. So if you don't have the video player, we're going to create the player, and we're going to instantiate video.js, pass video element, pass the video options. We assign the player ref current to be the player, and actually I'm going to remove this for now. This is going to be the player selector. So if you want to switch to 1080p to 720p, so if you want to manually switch the video quality, we can add a quality selector. For now, I'm just going to remove it and create the basic player. And here we go back here to this video player. Okay, so now we already imported here the CSS for video.js. Now let's create here div with a player ref. So video ref, sorry, actually should be, let's return here these two. Return video ref. Actually, we don't need to pass the player ref here as well, only the video ref. Video ref. Perfect. That's basically it for now. Let me see what I'm missing here. Video source here should be this. Oh yes, since we changed here to be video info instead of the new interface, then we need to pass the same properties. So video source is going to be the file URL, and the video meme type is going to be the meme type that we hard coded here into our code base. And that's pretty much it. And then video ref, pass the video ref here, video ref, player ref, video options, and then that's pretty much it. Now let's test it out, our application. Yarn dev. Let's go back to our browser, refresh the page. Yeah, something went wrong. Let me check what happened. Refresh. So, okay, so we're getting a forbidden. Let me check what's happening here real quick.
A few moments later.
Okay, great. After some debugging, I found what was wrong. So if we click here, now we can see that the video is actually playing correctly.
And the reason it keeps rebooting.
It's a bit hard to see because I'm recording the screen and playing the video at the same time, so it's a bit buggy, but the video is actually working. And if we open up here the inspect page, we refresh here, actually go to the network tab, we can see the playlist files which are coming from Cloudfront, and some of them we will see the signed cookies somewhere here. Let me check. Actually on the request, yeah, because I have some cache here, so we cannot see the response correctly, but we do have signed cookies. Okay, let me disable cache and refresh the page. Let's see if we can refresh the page, play it again. Okay, now we can see the cookies. As you can see, we're passing signed cookies and sending signed cookies to Cloudfront distribution. Then we can have the video which is protected by signed cookies, and that's pretty much it. Now you have a video.js React application which uses React on front end, NestJS on backend, and Cloudfront with signed cookies to distribute your content. So the things that was broken before are, so on the backend app, let's go back to backend. This is the backend app. So a few things that I've made wrong. I forgot to return the file URL. Yeah, my mistake, sorry about that. So I forgot to return here the file URL to frontend, which is this file URL. So we need this on frontend, which is the S3 key with the Cloudfront distribution. So this was the first mistake that I've made. The second mistake that I've made here, it was because the backend that I was using previously, it was not actually this code that you are seeing here right now. It was the one that I created previously to make my tests. So that code was pointing to a second Cloudfront distribution that I created previously. So what I've done here, so I used this zip project script. So I zipped the project, I created a zip file, and I sent this new zip file to Elastic Beanstalk. So once I send here the new code to Elastic Beanstalk, with the proper fixes, everything worked. Besides this, there's something else that I need to tell you that I forgot to do. This is our Cloudfront distribution. So on behavior tab, we also need on here on response headers this. So let's go to edit. So this flag here, origin override, it must be disabled. You cannot enable this, otherwise you're gonna have course issues. So these two must be disabled. So once I've made all of these fixes, I could properly see the video here on my front-end application with signed cookies. And that's it. Now you know how to configure HLS video streaming using Cloudfront and Signed Cookies with React on frontend and NestJS on backend. I hope you liked it, and I see you in the next time.